need to know. So we are starting with this unit. Again, we are still on Algebra 1. We have not traveled all the way to Algebra 2. The reason being, there are probably 2 more topics that we would need to get more comfortable with before we can jump onto the roller coaster of Algebra 2. But, come on. So, Siddharth, I will need your help. Beta. Can you press that red button to close the garage door? So, oops, just 1 second. Okay. So, Arya, I would need your help now to press that red button. I mean the button at the top. So, we are, Maya, you might want to come to the classroom. Or Arya is here. So we are starting with exponents, and I'm not going to deal with simple exponents. We are talking about, Nika. So we are dealing with exponents, but not the easy ones. We are dealing with rational and radical exponents. What does it mean? Who knows about what is rational and radical exponents? Siddharth? You don't know? Okay. Anybody else? Bhairav, Anika, Myra, Siddharth, Aryahi. What do you guys know about radical and rational exponents? Nothing? Okay. So, Siddharth, you have your topics that you...
Yeah, I forgot to send it. I just remembered to have
When is the test?
Tomorrow.
Man, you are not giving me any time.
I know, sorry.
It's okay. So, when did you get to know about it?
Like today, I just remembered when I got.
What are those topics? Any idea?
It's synthetic division, long division for polynomials, rate of change, and all the different types of factoring, like factoring higher degree polynomials.
No, that is quite a lot. So look at what you know and what you don't. But you'll have to certainly give me a day or 2 at least, so that I can prepare. Otherwise, if I don't get noticed.
I know synthetic and long division. I just need help with factoring.
Factoring, okay. We'll look at it, okay? After the class for 10 minutes. Okay. Hey Vasundhara. Can everybody hear me okay? I had one scary question. I mean, that's what you guys felt. And that question was, what do we mean by rational and radical exponents? And I did not get any answer. So that means we have not come across that before. Vaibhav, how about you? Vishwa said no, I heard that. How about Vaibhav, Vasundhara, any idea? No idea? Guys, you guys have to be more open with respect to sharing. It's okay to say I don't know. That is what gives us an opportunity to learn. Okay. Now, if I ask, what do you guys know about exponents? Everybody knows what is exponent? Everybody? Do you guys know what the 3 rules of exponents? 3 rules of exponents. Let's do that in a very simple way, okay? I'll go step by step. And I would request, I would not say beg, but I would request you guys to participate with me, okay? Anika, you're with me so far? So we are talking about exponents. What is exponent? If I have 2, it is 2. 2 into 2 is 4, but I can write that in a different way. 2 square. If I have 3 into 3 into 3 into 3, 3 is getting multiplied with itself 4 times. So I can write this as 3 power 4. These are the forms of repeating numbers where you are doing repeated multiplication of the same number by itself. And that is called exponent. Where this is your base and this is the power. Okay? So tomorrow if I say 7 into 7 into 7 into 7 into 7 into 7 into 7, how many times? 1, 2, 3, 4, 5, 6. So I'm multiplying 7 with itself 6 times. So 7 is my base and 7 to the power 6. That's what I'll say. Everybody okay with that? Yeah? Now, we are going to the next level, where I want to make sure that everybody gets scared of me hereafter. Because you guys are taking me very easy. Now, if I say 3 to the power 3 into 3 to the power 5, what does it mean? How much it is?
3 to the power of 8.
3 to the power 8. That's what Sid is saying. And I'm not saying that is wrong, but I'm doing that in a very simple way. Let's simplify it. 3 to the power 3 is 3 into 3 into 3. So this one is here now. Into 3 to the power 5 is 3 into 3 into 3 into 3 into 3. 5 times. 3 power 3 became this, 3 to the power 5 became this. How many 3's we have? 1, 2, 3, 4, 5, 6, 7, 8. So that is how you can represent this as 3 to the power 8. Hey Sanita. So, like what Sid was saying was that when you have two exponents getting multiplied with each other and you have the same base, you just add the power. So 3 to the power, so I can say if I have, let's say, exponent x, which could be 1, 2, 3, 4, 5, 6, whatever, to the power a times x to the power b, it will become x to the power a plus b. Okay, this is the first rule of exponent. Yeah? Biswa, Anika, is it okay? Baba, okay? Now, this is the first rule of exponent. Let's look at the second rule of exponent. If I have 5 to the power 6 divided by 5 to the power 4, how much that will be?
5 squared.
5 to the power 2. Yeah? But let's not assume anything. I don't trust Sid, okay? I'm not saying that I don't trust Sid. What I'm saying is, I never trust anything on face value without me being convinced, okay? So 5 to the power 6 is 6 times of 5, and 5 to the power 4 is 5 into 5, 4 times. Now time to play. 1 5 1 5 tic tac toe, 1 5 1 5 tic tac toe, 1 5 1 5 tic tac toe, 1 5 1 5 tic tac toe. What we are left with? 5 into 5. That became 5 to the power 2. So this says, if I have two exponents with the same base, when I am dividing one by the other one, if my bases are the same, I will subtract the power of the denominator from the power of the numerator. So this is how 6 minus 4 became 2. And we saw it happening in the simplest possible way. Yeah? Anika, Sundara, Sanvita, everybody agrees? Yeah? So we can generalize that as a second rule, where we saw that if I have one exponent getting divided by another exponent and both have the same base, my result would be an exponent with the same base, and power would be power of numerator minus power of denominator. This is the second rule. We can apply this for any number, be it 2, 3, 5, 7, 20, million, billion, trillion, whatever. Now the third rule of exponent. 5 to the power 3 to the power 4. And again, I'm rushing through it quickly because we have not still touched or seen the flavor of what is rational and radical exponents. I have an exponent inside the parenthesis and then I have power here. How much that would be?
5 to the power of 12.
So what I would assume is you will say 5 to the power 3 into 4. Okay? Tomorrow if I change something, you will know that you will multiply these two. Okay? So I know you know it. I'm just trying to make it explicit for everybody. And again, let's not worry about it. 5 to the power 3 to the power 4. That means whatever I have, that thing is getting multiplied with itself 4 times. Yeah, that's what it will be, right? Here be. Yes, Vishwa. Yeah, go ahead. Yeah, tell me.
Isn't it 75 times 75 times 75?
75? Why 75?
Because 5 to the power 3 is 75, right?
Nope. 5 to the 3 is 5 into 5 into 5. That gives you 125.
Oh, I mixed it up.
Yeah. No, so again, what I'm saying is, when you're dealing with exponents, don't try to expand it and then try dealing with it. You are better off dealing with exponents in the exponent form itself. Okay? So Abhi, you joined a little late, but don't worry, we'll catch up. Okay? So here we are dealing with exponents right now, and our goal today is to learn about rational and radical exponents. So I'm just looking at some of the basic rules of exponents. Yes, beta. Yes, please. So we are just looking at the basic rules of exponents. Here, I have 5 to the power 3 in parenthesis to the power 4. That means whatever I have here, same thing is getting multiplied by itself 4 times. Now, let's do one by one. 5 to the power 3 to 5 to the power 3 will become 5 to the power 6. And then you still have these two. These two will become again 5 to the power 6. Now, same base. You are applying the first rule. It becomes 5 to the power 12. Which is nothing but 5 to the power 3 times 4. See, if you look at it, you are adding 3, 3, 3, 3. Repeated addition is what becomes multiplication. So you will say, if you have something like this, that will become 3 into 4. So this is a third rule of exponent. And again, if anybody is having difficulty in catching up on this one, I'm just doing a recap of what is exponent. My goal is to learn something different for you guys. This becomes x to the power a times b. Okay? These are 3 rules of exponents. Now, is this what we want to learn? No. We want to apply these things for learning more interesting stuff. Is it okay so far? Anika, Vasundhara, Mayra, Sanvita? Vaibhav has been very quiet. Is it okay with us so far? It's okay? Alright. Now, life takes a U-turn. 25 to the power 3 by 4 into 25 to the power 1 by 8. So far life was looking easier, amiable, friendly. It's getting difficult now. So first thing first, I said rational exponents. When you are talking about rational exponents, what we are talking about is when you have exponents, meaning something as a base and the power of the number that we are dealing with, which is the exponent form, is a rational number. It's not a whole number or natural number. 5 to the power 2 into 5 to the power 3, you knew that okay, I have same base, exponents get added, 2 plus 3 gets added. But what about this situation? You guys will start worrying about, okay, I have power, okay, 2, 3, I know I can break it down. But in this kind of situation, how do I deal with it? It's the same thing. It also uses the same concepts that we have learned here. And that is what we will apply here. So, a rational exponent is nothing but exponent where the power of the exponent is in the form of a rational number. So when you are multiplying these two, same thing. 25 into 25, same rule will apply. Your base is the same, your power will get added. Nobody told us that A has to be natural number, B has to be a natural number, okay? So what we will do is, this will become 25 to the power 3 by 4 plus 1 by 8. And find it out, that is what your answer would be. Yeah? Is that okay? Now, I'm talking about the next problem. What do we mean by negative exponent? Negative exponent, as I keep saying, English is the mother of maths. Yeah, go ahead.
Isn't it like 1 over or something for negative exponent?
No. Yeah, no. So let's say, if I say negative exponent, meaning if I'm saying 6 to the power minus 2.
Yeah, it's 1 over 6 over, it's 1, and then 6 to the exponent, 6 squared, sorry.
6 to the power?
No, it's like a positive 1 fraction, 6 squared.
6 squared. And yeah, you're right with what it is, but whenever somebody talks about negative exponent, you are actually talking about an exponent or the power as a negative number. If you know 6 to the power 2, you know it's 6 into 6. But what is 6 to the power minus 2? 6 to the power minus 2 would be something like this. 6 to the power 0 minus 2. That is how you get a minus 2. That means related with this formula, it will become 6 to the power, see look at this, something to the power a minus b means something to the power a divided by something to the power b. So 6 to the power a minus b will become 6 to the power 0 divided by 6 to the power 2. That is how you got a minus 2. 6 to the power 0, any number to the power 0 is 1. So when you have negative exponent, you will see that you can move it from numerator to denominator and the sign changes to positive. That's what Sid was saying. Is it reaching everybody or I'm just rushing through it? So Vishwa is not clear, correct? You are clear, Vishwa, or you are not? I mean, I don't mind explaining one more time. I'm just trying to make sure that everybody is with me. Okay. Anika, are you clear, beta?
I'm clear.
I'm sorry?
I'm clear.
Oh, yeah, clear. Anika, Vasundhara, are you guys clear as well?
Yeah.
Yeah, that was a cold, yeah. Vasundhara is okay? Okay. No, so, fine. I'll just skim through this a little faster. But I have a very bad habit of not letting you guys go till I get confident. I don't know about you guys, but I get stuck. If somebody says 6 to the power minus 2, it simply means it will become 1 by 6 to the power 2. I'm just making this whole thing travel from numerator to denominator. And how that happens is because 6 to the power minus 2 I can write as 0 minus 2, and then I can relate it with this second rule of exponent, which says something to the power a minus b is equal to something to the power a divided by something to the power b. So this thing becomes 6 to the power 0 divided by 6 to the power 2. Something to the power a divided by something to the power b. That's what you're seeing here. Something to the power 0 is 1. So this is how the travel happens. Yeah, Nanya. You got a little late, beta, but we'll see how much we can catch up. Okay?
Oh, I had a soccer link.
I'm sorry, beta?
I had soccer practice.
Oh, okay. Yeah. So we are talking about exponents, which we have done in the previous classes, but we are not talking about exponents alone. We are talking about rational and radical exponents and negative exponents. Okay? So all the kids who have missed the initial part of this one, where we talked about these basic rules, you can just watch it and do some practice by yourself, okay? Ask some questions to yourself, okay? How about I have, let's say, 25 to the power minus 1 by 2. How much it is? 25 to the power minus 1 by 2. So I have an exponent which is a rational number or a fraction. So it is a rational exponent, but it's a rational exponent with a negative power. So it's a negative rational exponent. How much that will be, Siddharth?
Wait, what did you say?
I'm saying how much this will be, 25 to the power minus 1 by 2.
1 over 25 half exponent.
Can you simplify it further?
You can, I don't know actually.
Okay. Anybody in the class? I'm trying to find out the absolute value of 25 to the power minus 1 by 2. I'll give you 30 seconds to think about it. So Siddharth, what I will suggest is, take this notebook, write down some of the questions that you would want to try out. Okay, you can write down some of the questions. We'll pick up those questions, okay? Yeah. Anybody? How much this will be? 25 to minus 1 by 2. You guys are not playing yet. Yes, Abhi. Let's do one thing at a time. We just now saw that if I have something to the power minus 2, that is as good as 1 over something to the power this. This part is okay? Yeah? So, if I have something to the power minus 1 by 2, this will be same as 1 over 25 to the power 1 by 2. Yeah? And I'm trying to introduce a new concept here that is called radical exponent. So, 5 square is 5 into 5, which is 25. If I say square root of 25, how much that would be? Yes, Anita. 5. Yeah. So it's just the reverse, right? Square multiplies it by itself twice. Square root is trying to break it down to two numbers which are same and getting multiplied with each other, and you pick one of them. That is what is a square root. So here, this whole thing, 25 square root, you can also write in this form, 1 by 2. So when you have any number to the power 1 by 2, that is nothing but square root. Okay? So this form, this is also a form of exponent. This form is called radical form. When you represent something like a square root, cube root, fourth root, sixth root, that is represented with this notation, and that is called, this is radical form. So basically you can say 25 to the power 1 by 2 as a rational exponent form, and you can write the same thing in this way. This will be a radical form. Both are the same thing, just two different representations. Yes, Biswa, you had raised your hand. Go ahead.
So what if it's like 25 and then exponent to the power of like 2 over 4 would still be the same?
2 over 4 will be the same. But now I'm introducing one more thing that you guys would have noticed but might have overlooked. If I say this, I'm talking about square root of 2. You're trying to find out two numbers that you multiply with each other so that you get a 2. And you'll pick one of it, that will be your value. If you say square root of 5, you're trying to break this into something that results into 5, and that one thing would be the value of it, right? And there's something that is hidden here that we never bother to notice. Whenever we are representing this way, there's a 2 that is never visible, okay, that is hidden. So it is assumed that if you have this notation, we are talking about square root. If you remember, you will see that there are some numbers written like this with a 3 here, that is cube root. With a 4 here, that is a fourth root. There is a 6 here, that is a sixth root. Okay? So, if there is nothing here, we are talking about square root only. So now, if I say represent 25 to the power 1 by 3 in the radical, this is rational form, rational exponent form. In the radical form, I will write this as 25 and I will put a 3. Because everything apart from 2, I have to put a number here. So radical exponent, rational exponent, both are the same thing. These are just two different representations. Is that okay? Vasundhara, Sanvita, okay? Maida, okay? Okay, kids, I have a request for you all. In a 1 hour class, I would want to hear your sweet voice of yes or no at least 2-3 times. don't lean on those technical emojis to give your responses, because trust me, the eye contact that I'm making with Abhi right now, that gives me a very clear clue whether Abhi is able to follow me or not. If you are keeping your videos off, that is okay, but hearing your yes or no versus yes, no, gives me a very clear indication of how confident you guys are. And if you guys are low on confidence, my confidence shakes big time. Hey Kushi. Kushi keeps forgetting about me.
Hi.
Hello, beta. So, Kushi, we started this class 27 minutes ago. You got a little late. So
Sorry.
No, it's okay, beta. But the problem is you'll have to watch the video of the class, because no, we might not be able to cover everything that we have covered so far. But just to give you a summary of it, we are talking about radical and rational exponents. Okay? And it is nothing different. We just covered what do we mean by exponents and what are the basic rules of exponents. When you are multiplying two exponents with the same base, the power gets added. When you are dividing one exponent with another exponent with the same base, your power gets subtracted. And the third exponent is when you have exponent with a power, you have an exponent inside the parenthesis and then you have a power here, these two get multiplied. Okay, these are the rules that we just broke it down into easier ways to relate it, and these becomes our rule of thumb for dealing with any and every kind of exponents. Okay, so this is a basic rule of exponents, and when you watch the video better, you will be able to relate to it. And my request to everybody would be, whatever I do in the class, that might be very nonsensical in nature, but after the class, when you watch the video, try playing with it. So then you'll be able to confirm your understanding with and align that with whatever we are learning in the class. Now, the next thing we said, okay, these are the basic rules of exponent that you guys know about, and we are trying to extend that information to deal with other types of exponents, which are called radical or rational exponents. So when you say rational number is nothing but the fraction form. All these are called rational numbers. So when your exponent is in the form of a rational number, these are called rational exponents. Yeah. So what we were seeing here was, if somebody says tomorrow that multiply 5 to the power 1 by 2 into 5 to the power 1 by 2 into 5 to the power 2, it is nothing different from what you have already known. These are three exponents which are getting multiplied and the powers are different. When you are talking about multiplication of exponents with the same base, what you will do is you will keep the base same and add the powers. 1 by 2 plus 1 by 2 plus 2. This is what your outcome would be. So rational exponents are nothing different from the basic rules that we have learned. We can use the same way. It becomes 1 by 2 plus 1 by 2 will be 1 plus 2 is 3. So this becomes 5 to the power 3. Is it okay? Yeah? Kushi? I know this was a little late start, but are you able to follow me better so far? Are you okay? Sit okay? Now, so this is the rational exponent. You have, I'm not going to deliberate much on this one because I don't want to deviate you guys and say that okay, rational exponent is way too different. No, it follows the same basic rule. It's just a different representation style. If I'm talking about 5 to the power 2, I know I'm talking about 5 into 5. If I'm talking about 5 to the power 1 by 2, I'm talking about 5 to the power, which is a rational number. And this is same as square root of 2. So whatever you see as a denominator here, that goes next to the bracket, which tells you what is the root number that you're talking about. Okay. If I say 27 to the power 1 by 3, I'm talking about the third root of 27. Okay. So, or the cube root of 27. When you are representing this in the rational number form, exponent in the rational form, it's called rational exponent. When you are representing in this form, this is the radical notation. This is the radical exponent. So radical and rational exponents are the same, no different. These are just two different representations. Does it make sense to everybody? I am making Arya's sleepy. Okay. Myra okay? Abhi okay? Ananya? Khushi, everybody okay? Okay. Alright. Now let me give you guys some review. And these are the fun facts about the concepts that we learned. If I say find out 25 to the power 3 by 2. What am I talking about? Twenty-five to the power 3 by 2. What am I talking about? How much it would be? You guys have to get into the habit of playing with math. Okay? Before I turn 50, which is 6 months from now. Alright, so Myra and Aryahi knows about it. But yeah, I'm just making a public information that I want you guys to start playing with math before I turn 50, before I turn 51, whatever it is. But yeah, on a serious note. Now look at it. 25 to the power 3 by 2. Can I say 25 to the power 3 into 1 by 2? Can I say so? 3 into 1 by 2 is 3 by 2. Yeah? Now, look at it. 25 into 3, 25 to the power 3 into 1 by 2. Now look at this. When you have something to power A times something to power B, that becomes something to power A times B. What I will do is, I will put 25 to the power 1 by 2 here to the power 3. Yeah? Third rule of exponent. 3 by 2 I can write as 3 into 1 by 2, and I am putting 1 by 2 here in parenthesis and outside 3. Is that looking okay to you guys, or I'm missing something? Sanvita, Anika,
It's fine.
I'm sorry, Vita?
It's good.
It's good, okay? So now, look at this. So, when I have something power 1 by 2, that is nothing but square root of that to the power 3. Yeah? Because if I have nothing, that means it's a square root. 1 by 2 is nothing but the square root. 1 by 3 is nothing but the cube root. 1 by 4 is nothing but the fourth root. Now, do you guys know what is the square root of 25? 5?
5?
Yep, 5. Thankfully it is 5, not 6. Otherwise, you guys would have started singing a song. Yeah? So 5 to the power 3, that is 5 into 5 into 5. That will be 125. Yeah? So, again, whenever you come across this kind of thing, always look at this as a building block. This as your, what do you call, the brain for solving problems relating to exponents. Okay? Am I marketing these formulas more than needed, or it's okay? Everybody okay? Ananya okay? Vasundhara, Anika, everybody? Khushi? Okay. Alright. So we looked at what are the radical exponents, rational exponents. So tomorrow if you just, let's say, woke up and somebody throws one question at you saying find out the value of 64 to the power minus 3 by 2, it should not get you worried. Anything to the power a negative, anything to a negative power will translate into 1 over that thing to the power 3 by 2. And once you have it, you will say 1 by 3 by 2 I can write as 64, 3 by 2 I can write as 3 into 1 by 2. So 64 to the power 3 by 2, I can put this as to the power 1 by 2 and into 3. Now 1 over 64 to the power 1 by 2 is nothing but square root of 64 to the power 3. Square root of 64 is nothing but 8. 1 by 8 to the power 3. 1 by 8 into 8 into 8, 64 into 8, something. That's what it is going to be. Now, one last question. One question that I wanted you guys to take a look at before I start assuming that everybody is with me. Let me give you guys a chance to play with this. And while you guys are playing with it, I will disappear for 5 minutes so that you can do it with a peace of mind. And I will deal with one child here in the class who is waiting for me. Alright, so here's the question. 63 to the power, 63 into a b to the power 3 by 4 into c to the power minus 2 divided by 9 a to the power minus 7 into b to the power 1 by 3 into c. This was mesmerized by seeing the question. No, it's not. It might be looking scary to begin with. Don't get scared, because there are a lot of people who are trying to scare you with these kind of stupid questions, and they're actually not difficult. Let me read this for you guys. 63 into a into b to the power 3 by 4 into c to the power minus 2 divided by 9 into e to the power minus 7 into b to the power 1 by 3 into c. Simplify this, and here are the options you have. Option A is 7 e to the power 6 b to the power 5 by 3 divided by c. Option B is 7 bc cube divided by a to the power 8. Option C is 7 a to the power 8 b divided by c square. And there was one more option which I have not noted down on purpose because I want you guys to still solve it. 63a into b to the power 3 by 4 into c to the power minus 2 divided by 9 into e to the power minus 7 into b to the power 1 by 3 into c. And try simplifying it. These are 3 options that are given. There is one more option that I have not noted down because I want you guys to solve it. And I'll give you guys straight 5 minutes to deal with it. Okay? And if somebody has to ask a question, shout out for me. I'll be seen on the screen right after hearing you guys. Everybody heard the question, right? Everybody? Sanvita, Khushi, Abhi, Myra, Vaibhav, everybody? So deal with it. I'll be here. You'll hear my voice, but you'll not probably see me for next 5 minutes. Yes, sir. You're trying to factorize this. Yeah?
I don't understand how to factor of x squared.
So, see, always use some dirty techniques. So here, look at this. Look at these two. Here, between these two, what is common? X squared. And then there is hidden term. You do x squared here. What you are left with? 3x minus 2. And then let's look at these two here. Minus 9 is common, right? That is the GC between the 28 and.
Yeah. Can you do normal 9 as well?
I'm sorry?
Can you do regular 9 as well?
Yeah.
That's fine.
Yeah. 9, if I take 9 out, what we are left with? 3x minus 2. Same thing, right?
Yeah.
So this becomes x squared minus 9 into 3x.
Wow.
Yeah?
Yeah.
You can further factorize it. X squared minus 9. A squared minus 9 is b squared. So that becomes x plus 3. So this is 3 into x minus 3. Look at this guy. Here, what do you see here? 3x is common. 3x, there are only 3 terms. You cannot. You should take 3x here. X squared minus x minus 2. Now, it's a quadratic equation. You will try to find out what are the ways to factorize it. Now, if you remember, I have given you guys some.
Quadratic.
Yeah? No, I'll not go by quadratic formula. I'll go by, is it a perfect square? No, it doesn't look like. Now, I have x squared. So, a to c form. A into C is what? 2 minus 2 into 1 minus 2. What are the factors for this one? 1 and minus 2. This is what it is, right?
Yeah.
So now if I put these two together, what do I get? Minus 1. Wonderful. Matches. So I can say x squared minus 2x plus x minus 2. Yeah? That is how I split this x into these two parts. Yeah. I'm sorry. I'm sorry? Yeah, 100%. Don't even worry about it. So this one, now you take these two common. So now you probably appreciate what I was bothering you for. Here you take x common, x minus 2, and here you just take what common, x minus 2.
X minus 2, x plus 1.
Yeah?
Okay.
So all these here, see, look at this one. What is it? It will be easy to relate. Here 4x, 8x squared, 6x squared.
So can you split it in half and there's 4 terms?
Yeah. If there are 4 terms,
You always split it in half.
yeah. So look at these two. And again, you have to make some observation here. Here if I take 2x common, it becomes 4x plus 3.
Can you say
Here-
2x squared for half?
Why would you do that?
Because 8x squared and 6x squared.
Oh, it x squared?
Yeah.
I thought it's x cubed.
No, it's squared.
Then you can add them together. So this becomes what? 8x squared plus 6x
Let me
squared.
check for sure.
Yeah. It might be x cubed. That's what my hunch is. Yes, Vasundhara.
Yeah, it's x cubed.
Yeah. So you have to make some observation. Okay? So I'm just coming back. Just give me 10 more seconds.
Take 3x squared for both.
You can take 2x square common, it becomes 4x plus 3. Here 4x plus 3, so 1 common. This becomes a factor, isn't it?
Wait, what about for the last one? There's 2 different variables.
X squared,
And y cubed. I think it's x cubed actually.
x cubed, y cubed.
Yeah.
So here, this is this. This is 216. 6 is 36 into 6. So 6 cubed, x cubed, plus 125, 5 cubed, y cubed. So, I mean, a cube plus b cube. You have to look at what are the formulas that gives you a cube plus b cube. Just try finding out. Just do in Google. Just look for it. So I don't remember the formula actually. I can derive it. But net, what I'm saying is when you look at these things, you will be able to break it down.
Okay.
Yeah.
So for everything, I should just break and find the greatest common
Yeah.
factor.
Yeah.
Okay. Because at school, remember they taught us like different methods for each special type of
They
problem.
confuse kids.
Oh, okay. So for everything, I can just. I
No,
just-
80% of problems will match with this, and then quadratic formula, solving quadratic equation, factorizing quadratic equation that I have explained to you guys, a into c, and take the factors and see when you add them together, are you getting a b?
I also
Like,
don't fully understand differences for so this part. So if you have x squared minus 9, you automatically split it to like a positive and a minus.
yeah,
Like no matter what.
yeah.
Even,
It's a square minus b square. It's a plus b square minus b. That's it.
wait, can you also do it if it's like x cubed minus 9?
No, you cannot.
It's only if it's squared.
It's only square.
Okay.
Yeah. All right. Sorry, kids. I'm back. Vasundhara, what is that you got?
I got 7a to the 8
This one.
times b to the 512
Okay.
over c cubed.
So basically, none of the options that you see on the board, correct?
Yeah.
Love it. Let's see what Abhi got. That means you tried solving it. Wonderful. Yes, Abhi.
So, whenever they say, for the first time, whenever they say a and there's no value, would we just consider that being a to the power of 0?
1. Anything to the power 0 gives you 1. So if you have just this number, see, it's like this. If you look at 5 into 5, why it became 5 to the power 2? Because you had a hidden 1 here and here, and you added them together. If I had a 0 here, this will be itself equal to 1. Yeah? Any number to the power 0 is 1. How about everybody else in the class? Sanvita, Kushi, Ananya. Yes, Sanvita, tell me.
I got 7a to the power of 8 times b to the power
of 5/12 over c to the power of 3.
Okay. That means Sanvita was also trying to break her head with this problem. Wonderful. All of you, I'm sure everybody would have thought about it and would have made some attempt. How about you, Vaibhav?
I got the same answer, but I split that into half, so it's like C.
Are you okay?
The answer is C. Yeah.
Okay. So here's the thing, okay? These are the opportunities to play. Anika, do you agree? Whenever you have a problem to solve, treat them as an opportunity to play. Don't think about this being a stress factor, okay? I want you guys to always look at a problem as an opportunity to explore your knowledge and deal with it. Now look at it. I have A, nothing, that means a to the power 1, B to the power 3/4 as rational exponent. I have a negative here, I have negative here, I have 1/3 here. First thing you will always do is get rid of the negatives, okay? Negatives are always bothering us, okay, when we're dealing with that. So let's knock out the negative first. 63 is 63. A is okay. I'll write a 1 just for the sake of simplicity. B to the power 3/4, this is not negative, I'll not worry about it. C to the power is negative. That means I will move this guy down and then it becomes C to the power 2. Okay, so this guy is taken care of. Now let's come here. 9. A to the power 7, again negative. If I move it up, it becomes positive. So A to the power 7. So this guy is done. This guy, I will put a C and B to the power 1/3. Okay. Now it looks much cleaner. Now 63 I can write as 9 into 7. 9 7 is 63. 9 and 9 knocked off. So I have a 7. A to the power 1 and A to the power 7. When I multiply two exponents with the same base, my power gets added. It became A to the power 1 plus 7. This is with A. This one is done, this one is done. Okay. Now B to the power 3/4. Let it be. Divided by here B to the power 1/3 and C square and C, which is what? So this, when I multiply two exponents with the same base, my power gets added, C to the power 3. So now what we have is 7 A to the power 7 plus 1, 8 into B to the power 3/4 divided by B to the power 1/3 and C to the power 3. Now only thing is, these two are from the same family but not staying together. We want all the family members to be together. So let's deal with these two. Meaning, if I move this guy along with this guy or move this guy along with this guy, the power will change from positive to negative. So let's say I'm moving it upstairs. So this becomes 7 A to the power 8 into B to the power 3/4 into B to the power minus 1/3 because we moved it from denominator to numerator, and then by C to the power 3. Now when you are multiplying two exponents with the same base and different power, they will get added. So it will become 7 A to the power 8 into B to the power 3/4 plus minus 1/3, that is minus 1/3 divided by C to the power 3. So you have to add these two fractions. Basically subtract this fraction from this one, and whatever you get is what your answer would be. So if you look at the journey, did I solve a problem? No, I was literally playing with it. Because I knew that I have power negative, it comes down. If I have power negative here, it moves up and becomes positive. And that's exactly what I did. And then applied the basic rule of exponents. When 8/1 and 8/7 came on the same floor, 7 plus 1 became 8. When C to the power 2 and C to the power 1 came on the same floor, it got added, became C to the power 3. And then that's it. Did I say it wrongly by claiming that this was easy? It was not difficult actually. See, it's all about, see, you guys already have heard me so many times that I keep reminding you guys to get your hands dirty. See, I have evidence of my hands being dirty. See how many black dots you see on my hands. On a serious note, you have to get your hands dirty. If you don't do it, whatever I'm saying will sound only one thing, that is called gibberish. Am I making sense to everybody? Or I'm still talking gibberish? Everybody okay? Alright. So, Khushi, are you okay, beta? I know for Khushi and Ananya, you guys are a little late, so that's, I'm just trying to make sure that I'm making enough sense to everybody. Vasundhara, okay? See, Vasundhara is that you guys are all tech babies, okay? You guys only deal with technology. You don't say yes, you don't bother to say yes. You always show me likes or thumbs up, thumbs down. Okay, I'll give you guys one problem to deal with. 2 minutes to solve it, and as I did last time, I will again disappear to deal with Sid. Here you have a question 64 to the power 64 m to the power 9 and whole thing to the power 1 by 3 into 9 m to the power 7 n to the power minus 2 by 3. So here's the thing. 64 m to the power 9 into n whole thing in parentheses to the power 1 by 3 into 9 in parentheses again 9 m to the power 7 n to the power 2 by 3. Is everybody able to see the question on the board? Yeah? And here are the options that you guys have. So you have option A as 36 m to the power 63 n to the power 2 by 3. Option B is 36 m to the power 10 n. Option C is 36 m to the power 16 n to the power 5 over 3. Option D is 36 m to the power 21 n to the power 2 by 9. And if I have written any of the options incorrectly, don't worry about it. Try solving it with your playful approach, and then we'll talk about it after 2 minutes. Okay? I'll be muted for 2 minutes. I'm hoping everybody could see the question at least. Answer part, don't worry about it. Once you solve it, you will see which one it maps to. Yeah? Everybody saw the question? Say once yes. Now I'm getting a different emoji from Anika. That's okay, but as long as you guys can see the question and give it a try, I'm okay. Alright? Everybody? Vasundhara, Vishwa, Bhavan, go for it. Yep. Tell me, what is bothering you?
The last question.
This one?
I found a solution for it. This is actually my teacher did.
This is what your teacher did.
Yeah, for the last question.
So, see. Option B. Okay, I'll come to you. Let everybody solve it. I don't know what the answer is, and I really don't want to worry about it for now. I'll give you 2 minutes.
That's option B.
You also think option B? Okay. So here, let's see. C is saying that a cube plus b cube is equal to a plus b times a square minus 2ab plus b square. If this formula is correct, then what your teacher is doing is right. Let's check this. A plus b into a square minus 2a plus b square. That means a into a square minus 2ab plus b square plus b into a square minus 2ab plus b square. Okay? Now let's see, this becomes a cube minus 2a square b plus 2a, ab square, yeah, plus b into AB square minus 2AB square plus BQ. Yeah, 2A square B and 2, sorry, why did I rush for it? So 2AB square, this minus and these two, can be cancelled out. Yeah. AB square. I'm messing up. Let me see. It becomes AQ minus 2A square B plus AB square plus A square B minus 2AB square plus BQ. AB square, A square B, AB square, these two. No, this formula is not correct. If we have, no, this formula is not correct. Find out the formula on Google. What are the factors of AQ plus BQ? Okay, yes, Arya.
I'm still deciding between B and C, but I think it's B.
You think it's B? Everybody thinks it's B. I heard 2 B's and 1 potential B. What about Vasundhara, Myra, Abhi, Biswa, Sanvita, Kushi, Anika, Rania? Yes, Vasundhara, Toyota.
I think it's B too.
You also think it's B? Now, okay, let's look at it. What we have is 64 m to the power 9 n. So 64, if I just explode it, what happens? It says a to the power, x to the power a, the whole thing to the power b equals x to the power a times b. We'll apply the same thing for all of them. So this whole thing, if I break it down, this becomes 64 to the power 1/3 into m to the power 9 to the power 1/3 into n to the power 1/3. This part. Now this one is 9 into m to the power 7, n to the power 2/3. Now let's look at it. 63 power 1/3. 64. That is, we are trying to find out cube root of 64. Now 64 is what? 4 into 4, 64. 4 into 4, 16 into 4, 64. So the cube root of 64 will give me a 4. M to the power 9 to the power 1/3. So that is m to the power 9 into 1/3. That is how you use the third rule of exponent. Into n to the power 1/3. And then you have a 9 here. And then you have m to the power 7. And then you have n to the power 2/3. So this becomes 4, m to the power 9 to 1/3 becomes m to the power 9/3, that is 3. Into n to the power 1/3 into 9. So 4 into 9 becomes 36. I am putting 36 here. And then m to the power 7 into n to the power 2/3. What you will do is 36 remains 36, m to the power 3 and m to the power 7. When you multiply them, it becomes m to the power 10, 3 plus 7. And then when you multiply m to the power 1/3 and m to the power 2/3, it becomes m to the power 1/3 plus 2/3, which is also equal to 1. So this becomes 36 m to the power 10 into m to the power 1. Bingo. Yep. Did I do anything interesting? No, I was playing. I was literally playing. You guys could not see my face when I was doing it, but I was literally enjoying it. It was just a calculation. Yeah? With that being said, I'll let you guys go. And send you guys some assignment to play with them, not to get stress. I want you guys to start playing with it. Okay? Otherwise, this is going to be